Hi guys, this is Mr. Urrego, and today we're graphing rational functions with vertical asymptotes, horizontal asymptotes, slant asymptotes, and holes. Let's graph this one. We have a function. We have to follow a couple steps. My first step is to factor and find the domain. I gotta factor both numerator and denominator. Let's try to factor, holy cow, 3x squared minus 2. Let's try to factor this. So to factor this trinomial, I'm going to multiply leading coefficient times 1. So it's going to give me 3 times 1 is 3. And my sum has to be equal to negative 2. Two numbers that you multiply, you get 3. Not too many choices, 3 and 1. 3 times 1 is 3. But it's not going to give me negative 2. What about if they both are negative? That's going to give me negative 4. So no, I'm looking for negative 2. So this you're not able to factor. Okay, top. Nothing I can do. X minus 1, nothing that I can do, so that's factor already. Now I need to find the domain. To find the domain, I make my denominator 0. I take x minus 1 equal to 0. And the whole idea is that I don't want the values that make my denominator 0. So from here, I'm going to find the value of x, which is going to give me x equals 1. So this is the value that I don't want. So my domain is real, okay, but I don't want that positive 1. So my domain is all real such that the x is not part of my domain. All right. Next step. Cancel common factors. As we noticed, there's no way we can factor. So there's no common factors. Therefore, there's no holes on my graph. Step 3. Vertical asymptotes. Let's make the denominator 0. Okay. Same idea. I just made the denominator 0 because I needed my domain. So now my vertical asymptote is I make my denominator 0, which is the same thing. Therefore, the x equals 1 is going to be a vertical asymptote. All right, that was the reason it wasn't part of my domain, because it's an asymptote. All right, next. Step number 4, horizontal or slant asymptote. We have no idea, so let's bring the rules. The rules to find horizontal or slant asymptotes are the following. Okay, n is the exponent from, or the degree from my numerator. The m is the degree of my denominator. In this case, n is 2, m equals 1. So out of these 3 rules applies the last one. N is greater than m. N is greater than m. Okay, in this case, there's no horizontal asymptote. Okay, what about slant asymptotes? I gotta find out. In order for me to have a slant asymptote, my degree from the numerator has to be 1 greater than the denominator. I have a 2 on the top, which is 1 greater than the bottom. Therefore, I have a slant asymptote. What is this slant asymptote? It will be the quotient between numerator and denominator. So I gotta find that slant asymptote. Here we go. So I need to divide this numerator by denominator. What do? I do long division. So I'm gonna bring 3x squared minus 2x plus 1, and I'm going to divide that by x minus 1. Whatever my answer is, that will be my slant asymptote. So 3x squared divided by x is going to give me 3x, multiply back, 3x squared, 3x times negative 1 gives me negative 3x. As you notice, x squared under x under x. Remember long division. I put a negative here. 3x squared minus 3x squared cancels out. Negative 2 minus negative 3, this becomes positive. It's going to give me an x. I'll bring down the 1. And now I start over again. X divided by x gives me 1. And now I multiply back. 1 times x gives me x. 1 times negative 1 gives me negative 1. And because I'm doing long division, I'm going to put a parenthesis here and I subtract. X minus x cancels out. 1 minus negative 1 becomes positive, gives me 2. So my answer, this is the quotient, that's going to be my slant asymptote. So Right now I have y equals 3x plus 1. And now this is my slant asymptote. Next step. Step number 5. X-intercept. I make my y equal to 0. Okay? So basically when I have a fraction, I'm making my y equal to 0. So I have 3x squared minus 2x plus 1 divided by x minus 1. Alright, that means this fraction has to be equal to 0. When a fraction is equal to 0, the only thing that I need to make 0 is my numerator. Because if I have something here, if I have a 0 on the top divided by any number, let's say 3, my answer is going to be 0. So it doesn't matter what value you have on the bottom as long as it's not a 0. So when I'm doing my x-intercept, the only thing that I need to do is I need to bring my numerator equal to 0. So I'll take 3x squared minus 2x plus 1, my numerator, and of x equals 0. From there, I gotta find the values of x. Now, if you remember before, we tried to factor and we couldn't factor. Because we couldn't factor, then the only choice that I have is to bring the quadratic formula. Now, this is a, b, and c. I gotta find out if I can get values of x. X equals negative b, negative. Now, as we notice, we have a negative number inside the radical. Therefore, this is going to give me an imaginary number. Because this is not a real number, that means I don't have an x value. Therefore, there's no x-intercepts. Let's continue. By the way, there's a couple things that we need to address. Long division, I'll attach or link a video about that. Quadratic formula, hopefully we do that too. And here, imaginary number, which is complex numbers. I'll put that in the description, guys. Check the description so you can check those videos. Alright, I'll link them also at the end. Please, like the video. Alright, you understanding something? Please like the video. So that's going to show me that we are understanding what I'm teaching. Let's keep going. So right now there's no x-intercept. What's my next step? Y-intercept. For the y-intercept, I need to make the x equal to 0. So we make the x 0. So I'm going to do f of 0. Wherever you see an x, I'm going to be a 0. So this is going to turn into a 0 minus 2 times 0 plus 1. So technically, wherever you see an x, guys, that's going to cancel out. So this cancels, this cancels, this cancels. So that means I'm going to have 1 over negative 1, which is negative 1. So my y-intercept is negative 1. All right? What's next? So now our last step, almost our last step, is table of values. So we have a lot of information. Now we need to bring all that information into our graph and create a table of values. Let's bring all that information. So now we have this information, we got to put it in the table. We have to put it here on my graph. So let's start. Vertical asymptote equals 1. So my vertical asymptote, I'm going to put it a dashed line through x equals 1. Excellent. And this is my vertical asymptote. Vertical asymptote, x equals 1. Label, please. Slant asymptote, y equals 3x plus 1. My y-intercept is 1. My slope is 3 over 1, right? So I go up 1, 2, 3, and 1 to the right. 1, 2, 3, and 1 to the right. All right? 1, 1, 2, 3, and I'm going to connect those points. And that's my slant asymptote. Let's see if I can draw that line. I tried a couple of times already and I missed it. Okay, that's supposed to be a straight line going through this, right? And that's my slant asymptote. I'm sorry about that, guys. So this is my slant asymptote. Slant asymptote. Alright, so we're gonna graph our line with blue. So we know that this is the asymptote, this is my slant asymptote. Alright, and this is my vertical asymptote, which is x equals 1. Slant is going to be y equals 3x plus 1. Excellent. So I'm just trying to label everything. Now, we need points. We need points. The only point that I have is I have my slant asymptote and I have no x-intercept and my y-intercept. My y-intercept is -1. So that's the only point that I have. I need more points. Okay? So to get more points, the idea is on my x-axis, so I'm going to go by 2, this is 4, 6, 8, and 10, and so on and so forth, alright? So we know that every single box is 1. Now, this is the only point that I have. That means I'm going to have a graph in between these two asymptotes, okay? Remember, my vertical asymptote will never touch. We can cross horizontal asymptotes, but definitely not vertical asymptotes. So I need values. I need values to the left, I need values to the right. So basically, I have an asymptote. Let's find values here. So if this is a 1, all right, and this is 0, so let's do -1. Let's do -2. Okay. All right. So -1, -2 is going to give me some values over here. And now let's try next to the asymptote. Let's do 1/2. All this we're going to plug into the calculator, which I will do in a minute. After the asymptote, this is 1, so let's do 1.5. So 1.5. You're plugging this into your calculator right now. Let's do 2. Let's do 3. So the more, the merrier. Alright, that's the idea. Now, I want points really close to my asymptote. If it's possible, if this is 1, I want really close to the asymptote so you can see the behavior. Okay? 1.2. And then let's go far away and, 5. So all this is just table values. What I'm going to do is I'm going to plug this back into my original function. Let's bring the function. So let's plug the first value, f of -1. So it's going to be 3 times -1 squared. I'll do the first one and then I'll just complete all the table. X is -1 and plus 1. I'm replacing every single x by a -1. Okay, so on the top, -1 squared is +1 times 3 is 3. -2 times -1 is +2. So 3 plus 2 is 5 plus 1 is 6. So I'm going to have 6 over -1 minus 1 gives me -2. 6 divided by -2 gives me -3. So the first value is -3. Let's complete the whole table. Now it's a matter of just plotting values. -1, -3, -1, -3. So 1, 2, and 3. Okay, -2, -1, 2, 3, 4, 5, almost 6. So here we go. Okay, so 1/2 is -1.5. 1/2 is -1.5. So if you see the trend, my graph will be here, close to the asymptote, go over here, curve, and then go down, getting close to the asymptote. Okay. So if this happens, most likely the rest of the graph is going to be here in this corner between the two asymptotes. Okay, because there's no x, remember there's no x-intercepts. So let's go and plot the other ones. 1.5 gives me 9.5. 1.5 gives me 9.5. There we go. 2 gives me 9. 2 gives me 9. 3 gives me 11. 3 gives me 11. So 1.2 is going to give me 14.6. 1.2 gives me 14.6. So it's really high up here. 5 is going to give me 16. 2, 3, 4, 5, 16. So it's really up here. So the idea is now I'm going to have this graph curves and goes back. Alright, so somehow there's some symmetry between those two asymptotes. And that should be my graph. Alright guys, please like the video. Go over it again. Subscribe if you haven't subscribed, and I'll see you in the next one. Take care. Thanks for watching. Bye-bye.